Hello everyone. So just to recap the entire thing, you have to do the exact same project that we'll be doing in today's class. Okay, there's no change in that. Uh, how to submit the project, where to submit the project, the entire process. I will be making a video for the same. I will be uploading it on YouTube between 24 to 36 hours after the end of today's class. The link for the same will be shared on all the WhatsApp groups as well as the Telegram channel. Once that has been done, between 24 hours to 36 hours, once that has been done, after that particular point of time, 48 hours will be given to you to complete the project and submit it as well. So it will be very easy project. It won't take more than 30 minutes to make the project. Okay, do not worry about the same. Everything will be sent to all the Telegram channel as well as the WhatsApp groups as well. So do not worry about the same. It will be a very basic project on machine learning. Do not worry about the same. This video Sona is available on YouTube for the rest of your life, and you will get almost like 72 hours to make the project. So that's more than sufficient for making the project. Okay. Yeah, today we'll be doing the coding part. And of course, today is the last date to enroll for the data analyst training and internship program as well as the full stack web development training and internship program. So today is the last day to enroll. If you guys want to get enrolled, you can do it. But today is the last day for the 1st of June batch. So we'll be starting with the data analyst training and internship program from tomorrow, as well as the full stack web development training and internship program for tomorrow. Okay. I've not yet explained the project. Okay, we'll be doing the project right now. I've not yet explained the project. Please be with me. You do not need a PC to complete the project. You can do the entire project on Collab using your phone as well. Okay, so do not worry about the same. Okay, so let's get started, guys. I think so. The time is up and everyone has joined again. So the project that we are going to do today, you will be doing the exact same project. It will be a very easy project in machine learning. Do not worry about the same. I will be explaining every single line of code. So please be very patient with me and you will be learning everything. Do not worry about the same. The second thing that you need to keep in mind is I will be uploading a video on YouTube on how to submit the project, where to submit the project, the entire process. This video will be uploaded after 24 to 36 hours of the end of this particular bootcamp. Okay, that is today. So after today, it will take me 24 hours to 36 hours to upload that particular video on how to submit the project, where to submit the project. The link for the same will be shared on all the WhatsApp groups. Okay, on all the WhatsApp groups as well as the Telegram channel, so that you can start submitting your project. Once I've shared the link, you will be given additional 48 hours after that to make the entire project and submit it. The project will take just 30 minutes to make at the maximum. Just 30 minutes. So please keep that in mind. We are giving you ample of time, almost 3 days, to make a 30-minute project. So I hope that almost every single one of you is able to make the project. I will be live coding the project in this particular video, and this video can be taken as a reference to make the entire project. Code will not be provided for the project. You have to take this particular video as a reference to make your code, and this video will be up on YouTube like always for the rest of your life. So do not worry about that as well. This will be a very easy Python and machine learning project. Okay, again, so for the last date, there is no last date for our any of our batches. Like, of course, like one day before that is the last day. That is the 29th of June. Then of course 28th of June is the last day for the batch. But we only have limited number of seats. Currently for 29th of June batch, we are having 60 seats remaining in the data analyst training and internship program. So as soon as the seats are filled up, we stop taking in people. Okay. Okay. So let's get started, guys. Okay, so this is the project that we are going to do. I'll be showing the entire, so in the second video that I'll be creating, I'll be showing you what you have to submit as well, but this is the exact project that you'll be coding. But in that project, what and how to make the project, I'll be showing in the separate video, how to submit the project and everything. Okay, so please wait for the second video so that all your doubts will be covered in that particular video. So do not worry about the same, guys. Okay, again, this particular project you can do it from your mobile phone as well. Just take up a like collab, open collab.research.google.com on your mobile, and it will work on your mobile as well. There will be no problem with the same. Okay, so let's get started, guys, with the project. Okay, we will not be wasting any more time. It's, as you are able to see, it's a very small and very easy project to make. It will be very easy, guys. Do not worry about the same. I will be taking every single line of code and I will be explaining it. So please be very patient with me. Okay, this notebook will not be provided anywhere. Okay, this notebook will not be provided anywhere, so please keep that in mind as well. Okay, so let's get started. We are having our import numpy as MP. Okay, so what is numpy? Let us go and search for it. NUMPY numpy. Anytime that you are not able to understand any particular word, just search for it on Google. That's as simple as possible. NumPy is basically a mathematical, so you have a lot of matrix and multiplications and various different computations that you need to do on matrices. When you go into machine learning, it's basically at the end of the day just matrices that you are using and manipulating. So all these manipulations of matrices usually using Python is very long. Okay, it will take like almost 3 or 4 minutes to do a simple mathematical calculation upon that. To make the entire thing faster, NumPy is basically an entire package that is available in Python to make those computation a lot faster. It has been optimized. This entire thing has been optimized so that you are able to do computations on these type of matrices. That matrices like 2D matrices, 3D matrices, and so on and so forth, extremely fast. And that's why this package is extremely popular within the data science community, because at the end of the day, your data is basically 2D matrices. That is what I'm trying to make you guys understand. So this is what we are going to use as one of the first libraries that we are going to use for making the entire project. The second library that we imported was pandas. So pandas need to be installed as like in data analysis, you have a lot of different tabular data that you need to deal with. Okay, these type of tabular data that you have, that data needs to be manipulated very frequently. I'm not talking about computations. I'm talking about adding more rows, adding more columns, manipulating the data present in the entire table, and so on and so forth. So these type of data needs to be manipulated very easily, and pandas is a library that has been created to manipulate these data sets. Okay, all these data sets is basically the entire table as well. Okay, the entire table is something that you will be using. Okay, Ayush, I've already told how to create the project itself, that I'll be telling you in the separate video. In this video, the core concepts and the entire project, that is the aim of this particular video. Okay, that is what I'm trying to make you guys understand. So pandas is basically a library in Python language that basically offers various different manipulations, various different things that we can do on these type of tabular data very easily. Without writing very long lines of code, you can easily manipulate the data using a single or 2 lines of code itself. That is what I'm trying to make you guys understand. These are the first 2 libraries that we are going to use. The third library, also called as a machine learning framework that we are going to use, is sklearn. Okay, sklearn is a machine learning framework that has been built in Python, and basically what this is that it's a framework used for machine learning. You have various different machine learning algorithms. Of course, you are not going to write the entire algorithm from scratch every single time you want to use that algorithm. So someone has done that for you. All the algorithms have been built up in their own libraries, in their own functions. They can just import the sklearn library and use those functions to create your different type of algorithms. You want to do linear regression, you want to do k-means clustering, you want to do anything, upclad or any other priori algorithms, any algorithm that you want to do, you can do it easily using the sklearn algorithm. Now, sklearn library, okay, so this is a framework in machine learning. It is famous for its machine learning algorithms only. Okay, it is famous for its machine learning algorithms. So when you go into like deep learning, when you go into like all those deep learning neural networks and everything, there the TensorFlow library or the PyTorch library are the most famous libraries that are present. So that is also something that I've just like, I'm going to tell you, okay. Okay, so sklearn, that also something that I've just like, this is just an introduction guys, so that you are familiar with what I'm trying to make you guys understand. Okay, so moving on to the next line. So now we are writing import numpy as np. So let me just zoom in a little bit. Okay, so we are writing import numpy as np. What does this line means? We want to import, okay, we want to import numpy, that is the library that we have, okay. We want to import numpy and we want to name it as, so instead of writing numpy again and again whenever we want to use numpy, I'm assigning a pet name to numpy, okay. I'm assigning a short name to numpy. I will be calling numpy as np from now on. Okay, I will be calling numpy as np from now on. So I'm just importing numpy and I'm calling it as np. Okay, import numpy and I will be calling it as np. Shivani, I have already said that to get the second video, it will be uploaded on YouTube and the link for the same will be sent to all the WhatsApp groups as well as the Telegram channel. Okay. Okay. It's just a single project. I will be discussing about the project right now after this particular line, as you are able to see. So please wait, please be very patient. Okay, do not hesitate and please be very patient. Okay. Okay, so numpy, import numpy as np. So we'll be importing numpy and then we'll be having as np, that we will be having as like we'll be calling numpy instead of numpy, we'll be calling it as np, so that we are easily able to like that, just understand is that a pet name that we have assigned to numpy. Similarly, import pandas as pd. So instead of calling it pandas again and again, we'll be calling it as pd. And then we'll be having sklearn. Usually that can also be called as sk, but right now I've just used sklearn just for the clarity of the entire thing. I'm just connecting it to the backend again. sklearn is basically a machine learning framework, again a library in Python that contains all the different machine learning algorithms that you can use by just like you just have to write a single line of code in sklearn and that will call off your entire machine learning algorithm. You do not have to write the entire algorithm from scratch. Someone has made it for you. You just need to import it. You just need to use that particular algorithm and provide some inputs to that particular function, and that's it. That's it. Okay. Okay, so let us import numpy, pandas and sklearn. Once this particular line has been run, we have already imported numpy, we have imported pandas and we have imported sklearn. So right now let us try to understand what is the project that we are going to build. So we are going to look forward to the Boston dataset. Okay, so let us try to look at something from the Boston dataset itself. So BOSTU and Boston dataset. Okay, yeah. So Boston dataset is basically a Boston housing dataset that has been collected by the US Census Services for the housing in the area of Boston, Mass. Okay, so Boston is a place in US, you must be familiar with it. So US Census has collected this particular dataset upon the housing scenario in Boston. Okay, so what are the different things that are available right over here? So per capita crime rate in the town. So for every single 14 attributes that are present for each case of the data set. Okay, so basically the aim is to predict the price of a house. Okay, that is the final aim for us. Like if given all these different inputs, what will be the price of that particular house? So we are having a per capita crime rate by town. Okay, proportion of residential area zoned for lots over 25,000 feet. These are some of the technical things that will, when you go into buying houses, this will be important for you. Now, you need to know that this particular data set had been made many years ago. At that particular point of time, it was a case that the portion of blacks by town. So how many black people were present in the entire town? That is something that you need to understand, that this is something that is a lot like in the past, of course, but still, like that at that point of time it was necessary for people to understand how many blacks were living at that particular point of time in the town itself. That also affected the cost of the entire house. So these are the different, like these are the 14 different attributes that we have been given, based upon which we will be selecting the price of the house itself. That is what I'm trying to make you guys understand. So for example, average number of rooms per dwelling, nitric oxide concentrations, Charles River dummy variable, 1 in tract bounds river, a 0 otherwise, and so on and so forth. So that is what I'm trying to make you guys understand right over here. So these are the different like the data set that will be available to you. These are the different information that is available in the entire data set. Okay, that is what I'm trying to make you guys understand. So let us go back to our notebook. So this data set that we are going to use, we are going to predict what will the cost of the entire house based on the various different attributes that has been provided to us. So first of all, we need to have from sklearn.datasets. So you are having your sklearn library. In that we are having a a module called as datasets. The datasets module has a lot of different datasets available right over here, and we can directly import it and use it. You do not need to download anything, you do not need to upload anything, nothing of that particular sort. You just have to write from sklearn.datasets import load Boston. So load Boston is basically a function present in the module called as datasets. Upon calling this particular function, it will download and save the entire dataset into a variable called as df. Okay, the entire variable called as df. Okay, so many people are saying that the screen is too much blur. So for them, I will just I know that many of you are using YouTube for the first time. No problem in that. I will just help you out with that. You can just go to a new page. Okay, so this is what you will be able to see right now when you are going to the current page. And we are having some ads right over here. Okay, so this is the website that you are able to see as of this particular moment. Just a second, too much ads on my mobile phone. Okay, so you are having this particular thing that you are able to see. You can go to the settings. Okay, the scroll wheel right over here. You can go to quality and you can improve the quality to 720p, and then you will be able to see everything right over here. Okay, great. So again, going back to the, okay, so this is the attendance link as well. So just shown the attendance link. Okay, so going back to the entire thing, we are having your from sklearn. So sklearn is basically our machine learning library, machine learning framework that we are having. After that, we are having our data sets. Okay, we are having the module called as datasets inside sklearn. So sklearn.datasets. And then you are having import load Boston. Load Boston is a function present in sklearn datasets module, and that is what we are going to use to load our dataset. Okay, that is what we are going to use to load our dataset. So to load our dataset, we are going to first of all save it. Okay, so for df, so we have created a variable called as df, that is data frame. We are calling it as df. It's a variable. Df is equals to load Boston, that is a function that we are having. So df is equals to load Boston, and we are calling the function. So this will download and load the entire data set inside this particular variable called as df. So when I'm running this particular line of code, you'll be able to see that the entire df now contains your entire, let us just see. Okay, so I'm just writing df right over here, and you will be able to see that the entire data set is now loaded. So this is the entire data set. Okay, so a lot of gibberish right over here, but this is the entire data set that has been loaded inside of the df function. Okay, inside of the df variable, you are having the entire function saved right over here. Okay, so let's delete it from right over here. So df is equals to load Boston. Load Boston will download and load the entire data set, the Boston housing data set, inside of your df variable. Okay, so df basically is a particular dictionary. Okay, you need to understand Python dictionary is not something that we have dealt with as of this particular moment. So first of all, let us try to understand what is dictionaries in Python. So what is dictionary in a normal life? Okay, in our normal life, we are having a dictionary, an Oxford dictionary. You must be very familiar with an Oxford dictionary. So this is the entire thing. Okay, this is the entire thing as of right now. This is how you see your entire dictionary, Oxford dictionary, in your normal sense itself. So what you are having on the side are some markings that you are having on the side. Okay, these are some markings on the side of the entire thing. So for example, if you want to open up the entire like number of words that you are having starting with O, okay, you want to like put up all the letters starting with O, just count. Okay, so A, B, C, D, E, so this is O, this is for O. So you'll just open it up from the entire dictionary from right over here, and you will be able to find all the words starting with the letter O. Okay, this is how a normal dictionary works. Okay, this is a normal dictionary and you do not have to like make any like brain in this. Now think of this particular marking as your key. Okay, think of this particular marking that you were able to see. So you just went to that particular key, you want to open all, you want to get all the values. Okay, so your values is all the words starting with the letter O. Your values are all the words starting with the letter O. You want to get, okay, you want to get all the words, you want to get the value starting with the letter O. So what you will be doing is you will come to this particular key, you will come to this particular key of O, open it up, and you will be able to get all the values that you want starting with the letter O. Dictionaries also work in the exact same manner. So what you will be having is, you will be having a key and an associated value with the same, and this is one element. Just like in your list, you are having a particular string, okay, as a particular element in that particular list. Here in a dictionary, you are having a key value pairs as your element, a single element in the entire dictionary. So let us try to understand it from right over here. So a dictionary will be represented something like this. So you're having your curly brackets and then key, then value, comma key, then value, comma key, then value. This is how a normal dictionary is represented in Python. Okay, that is what I'm trying to make you guys understand. Now if I want to get this particular value, okay, this particular like dictionary is called as M. Okay, the name of this particular dictionary is M. If I want to get this particular value, okay, so let us name it as key 1 value 1, key 2 value 2, and key 3 value 3. Okay, let us take up some other color. Key 1 value 1, key 2 value 2, and key 3 value 3. Okay, so these are the like different key and value pairs that we are having right over here. If I want to access this particular value, if I want to access the value 2 from right over here, what I will be doing is I will just be writing M, that is the name of this particular dictionary. Okay, it will be the name of the entire dictionary, and we will be having your key. Okay, so instead of having your index, so whenever you were accessing, when in your normal list, okay, you are having a normal list of like value 1, value 2, and value 3. If you want to access value 2, what you will be writing is M of the index of 2. Okay, index of 2, whatever the index is of value 2, you will be accessing that and you will get the value as value 2. As simple as that. But in the case of dictionary, you cannot have indices. You do not have indices. Think of the keys as your index. Think of these keys as your index. To access the value 2, you will be using M of key 2, and that will have the value 2. That will have the value 2. Okay, let's try to understand. Let us have a particular list right over here. Okay, let us have a list right over here. And we'll be having in your list, you'll be having your value 1, val 2, val 3, val 4. Okay, in this list, when you want to access val 2, okay, the name of this particular list is M. Okay, name of this particular list is M. You want to access val2, what you will be writing? M of 1. Okay, M of 1, that is refers to your val2. Now if I want to make the exact same, if I want to make this exact same list as a dictionary, how will I do it? The exact same list. I want to do the exact same list as a dictionary. How will I do it? M is equals to 0 is the key, that is the index, and the value is val1. 1 is the key and the value is val2. 2 is the key and the value is val3, and so on. This is how I will be making the entire dictionary. This is how I will be making the entire dictionary. Okay, so that is what I'm trying to make you guys understand. Now even if I want to access val2 once again, I just have to write M, the key that is present, that is 1. So just like in your normal dictionary, you wanted to access all the words starting with 0, you use that particular key to access all these words starting with 0. Similarly, in a dictionary as well, if you want to access the value 2, you will be using its key. So M of 1 will be equal to your value 2. That is what I'm trying to make you guys understand. Okay, that is what I'm trying to make you guys understand from right over here. Are you able to understand or not? Is that a problem with everyone? Is everyone not able to understand, or there are just 2 to 3 people who went away to check the attendance link and hence they are not able to understand because they have missed every single thing? Because there are 2 types of people who waited, who knew the attendance link is right over there, and they waited in the class, understood everything, listened to me properly. And there's a second type of people who went away for the attendance link and then came back. If you're coming back, you will not be able to understand anything. That's on your fault, not mine. Okay? Understood, sir. Those who stayed behind, listen to me properly, they will be able to understand because I'm making it as simple as possible. Like I've not made it like anything too out of the ordinary. I even like made it very similar so that you are able to understand it with lists as well. Okay, great. So that means that those people who left and went for the attendance thing and came back, they are not able to understand, and the rest of the people are able to understand. Okay, that's great. Amazing. So that is the concept behind dictionaries. Dictionaries contain the key and the value pair. You want to access a value, you need to access it by the key. There is no indices in that. You need to access the value by the key itself. Okay, that is what I'm trying to make you guys understand. So similarly, right over here, the entire data set is available to us as a dictionary. Okay, so if I go right over here, if I have a particular like okay, I will write a code. Okay, type. Okay, I will have the type of, and then I will be having your df. I want to check the type of df. Okay, just running sklearn null bunch. Okay, so that is not what I wanted to show you guys. Just try to understand this, that the entire type of the entire object df is basically dictionary. Okay, that is what I'm trying to make you guys understand. The df, the data frame, is something that has been made from us as a dictionary itself. Okay, so it's a dictionary, and let us see right over here. So I want to access all the keys. I want to check all the keys that are present in the dictionary. So I will be accessing df.keys, and that will return all the keys present in the data set dictionary. Okay, it will give me all the keys that will be given us as a data set dictionary. So I'm running this particular line of code. You will be able to see that dictionary keys are data, target, feature names, description, and file name. So we'll be looking at each of these things about the dataset. So for example, the description is basically contains the description about the dataset. Okay, the value that is contained in the key description is the description about the dataset. So when I'm printing it out, print df.des CR. Okay, that is, I'm just printing out the entire description on my entire screen. You'll be able to see that the Boston housing price dataset characteristics, number of instances. So there are 506 houses that we are having the entire information about. Okay, there are 506 houses upon which I have the information about. That is the number of instances that you can think about as the number of rows in your table. Okay, think about it as the number of rows in your table. There are 506 instances of houses upon which I am having the information. Okay, number of attributes. There are 13 numeric or categorical predictives. So what is the 13 categorical or like numeric predictives? So that is basically the number of columns that you are having in the data. Okay, the number of columns that you are having in the data, that is what you are getting from right over here. So attribute information that we have already seen on the website as well, the same thing is written right over here, that each of these columns, what is the meaning of these columns? Okay, what is the meaning of these columns, that is given in this particular description. Missing attribute values, there are no missing attributes values, so there is no value of a particular house that is not there. So for example, for a house, I do not have the number of blacks living in that particular area, or number of rooms that is present in that particular house, or number of schools that is present in the locality of that particular house. I do not have that value, then I will be writing null or none. Okay, so there is no none values in the entire data set. That is also given right over here. Okay, and the creator is Harrison D and Rubinfield DL. So some information is given to us right over here. Okay, so yeah, so this is just some type of information given to you about the dataset itself. Now let us look at the other things as well. So let us look at data. Okay, so let us look at so we have feature names. Okay, let us look at what is contained in the feature name itself. Let us run this right over here. Inside the feature name, you are able to see it is given all the names of the columns that we are having. Okay, all the names of all the columns that we are having is being given in the df feature names. Feature names is again a key in the data dictionary, and that basically contains all the names of the columns that we are having. Okay, so file name is something that we can see again. So file name is basically where that file is stored right over here. So that has been given right over here, that where the file has been stored. Okay, what is the use of the description? You need to understand what kind of data has been provided to you, what are the names of the different columns, what are the properties of that particular column, what are the number of rows that is present in that particular column, what are the number of columns that are present in that particular column. So all this information about the column, a metadata about the data itself. So description, think of it as the metadata. Okay, about the data, some data that describes the data that is present in your description, just to get an overall understanding about the data set itself. Okay, so next what we'll be doing is, if we have looked at file name as well, file name basically stores where the file is stored right now. Then we are having your target. So we looked at feature names, we looked at description, we looked at file name. Now we are going to look at target right now. So in target, that will be storing our entire target. What is our target right now? What is our aim? To predict the prices of the house. So that prices of the house itself is your target. Okay, we need to predict the prices of the house, guys. So that is your target. So target will contain an entire list. Okay, this is containing an entire list. As you are able to see, this is a plain list of all the values, all the cost of each and every house that is present. So there will be 504 or 506 houses that we are having. So all the different prices for each of those house, that is present right over here in this particular target key. Okay, the value present inside the target key is basically the cost of all the houses present inside a list itself. Okay, and then in data, of course, the entire data for the entire thing is present. That is of course understood from the name itself. So it contains a list of lists. Okay, for each column there's a list, and all lists are present in the final list that contains the entire data. Okay, so that is what I'm trying to make you guys understand right over here. I'm just trying to make you guys some information about the entire data set, what has been provided to you as of this particular point of time. Okay, so now what we are going to do is, we are going to convert our dictionary, Okay, we want to convert our dictionary from a dictionary to a tabular data. Okay, we do not want to use a dictionary as our data. We want to use a tabular data as our data. That is called as a data frame in pandas. Okay, think of the like Excel type of data that you are having, rows and columns, proper rows and columns that you are having. So that is something that is called as a data frame in pandas, that is much more easy to manipulate and to use when compared to dictionaries, and much more faster to use as well. So what we are going to do right now is we are going to convert the current dictionary, the current DF dictionary that we are having, into a data frame. A data frame is the tabular representation of the entire data. We are having Boston is equals to pd.data frame. That is how you convert, how you make a data frame itself. So pd is basically a pandas, and we want to make a data frame. Okay, so this will contain first of all df.data, that is the data that we want to have, and columns. What is the name of all the columns that we are having? That is present in df.feature names. So we have already seen what does df.feature names contain. It contains the names of all the columns that are present right over here, as well as df.data. df.data basically contains the data for each of those columns. For each of those columns, the data is contained in df.data. Okay, and your df.feature names contains all the column names that we want to have. So df.data is one of the inputs that we need to feed in into this particular function, and then you will be having your columns. So naming all those columns, so columns is equals to df.feature names. Okay, columns is equals to df.feature names. So when I'm running this particular line of code, you will be able to see that my entire data set has been made. For each of the data that I was having a separate column. Each of the column is having a separate name that has been taken from the feature names that we are having, and we are saving the entire data frame into a variable called as Boston. So we have created a variable called as Boston, and we are saving the entire data frame inside of that. Next, we are having Boston.head. That will give me the first 5 lines that we are having. Okay, the first 5 lines, that is 0, 1, 2, 3, 4. The first 5 lines of the entire data set will be printed out, so that I'm able to see that, okay, everything is looking absolutely fine. There is no problem with that. Okay, that is what I'm doing right over here. Okay, so we are having Boston.head. Okay, we are having Boston.head. So we are having Boston is the name, is the variable inside of which we are having your entire data frame stored. Okay, and we are having Boston.head to print out just the first 5 lines. We do not want to look at the entire data set containing 506 lines of code. Why do we want it on our screen? We do not want it on our screen. I just need to look at the data, the first 5 lines of data, to understand that, okay, everything has loaded up, all my code has worked perfectly. So if I want to look at the first 20 lines, so I can just write Boston.head 20. By default, the value is 5. Okay, if you're not mentioning anything, only the first 5 lines will be printed out. If I want to look at the first 20 lines, I can just put up Boston.head. Then inside the parenthesis, I can just put up 20. And when I'm running this particular line of code, you will be able to see that first 20 lines of the entire data set is being printed on my screen. If I want to print the first 100 lines of that is present, first 100 rows that are present in the data, I can just write 100 and will print out the first 100 lines that is present. Of course, it will not be able to print that much, as you guys able to see, but still, like, you can do that. So I will just keep it by default to 5, because we do not want to have all the lines printed on our screen. That is unnecessary. That is taking a lot of space, a lot of memory. We do not want that. I just need to understand whether everything has loaded perfectly or not. So I will be putting Boston.head, and that will give me the entire line working right over here. All the different lines, okay, that I need to understand. Okay, so all the 13 columns are coming up appropriately, or the names are coming up appropriately, every column is being assigned properly. I've checked that, it's all good, and then I can go on with the next line of code. Okay, adding a new column of the target variables to the data frame. Currently this only contains the data. Okay, it only contains the data that we are having. It does not contain the target, because target was not contained in df.data. If you guys remember, target was contained in df.target. Okay, the prices that we want to have, that is contained in df.target and not in df.data. df.data contains the column values. It contains the column values that we will be utilizing to predict what is going to be the price, that is the target. So we need to have, so this is a particular like data frame that we have created right over here. We need to add one more column at the end of the entire data frame containing the values of those particular houses. From right over here, we are having the entire values present right over here. I want to have another column present at the end of the entire thing to have the target values also present in the same data frame. Okay, so right over here I will be adding a new column of target values to the data frame. Okay, so what we will be doing is we are having Boston. We will be creating a new column. So we'll be creating a new column. It is very simple to create a new column inside a data frame. Just have to write Boston, and then inside the parenthesis, inside the square brackets, you just have to name that particular new data frame. Okay, you just have to name the new column inside the data frame. Okay, you just have to name the new column inside the data frame, having Boston and then MEDV. That is the new, that is the like what you want to predict. Okay, so you are having your Boston MEDV, that is your what you want to predict at the end of the day. Okay, so you are having Boston MEDV is equals to df.target. So that will save all the values that you are having in the target key, the value present inside the target key, that is the prediction that you want to do, as your next column, as your end column that will contain your target values. The target values is the prices of the houses. The target values is the prices of the houses. So when I'm doing, okay, so once I've done that, I need to check whether it is loading up or not, whether it has completed or not. So I will just use Boston.head to print out the first 5 lines of the entire data set, just to see whether whatever modifications that I'm doing in the entire data set is coming to our screen or not. Is it coming to our data set or not? To check that, I'm using your Boston.head. Okay, to check that, I'm using your Boston.head. Okay, MEDV is basically the name I have assigned to the new target column. It can be anything. It can be target. It can be anything. But the name that I've assigned right now is MEDV. Okay, so Boston MEDV is equals to df.target. That will create a new column at the end of the data frame named as MEDV that will contain all the target values inside of it. And I'm just checking whether this is happening or not by running this, by having Boston.head, so that I'm able to check whether that changes have been made or not. I'm running to the right line of code. You will be able to see that MEDV is a particular column that we are having right over here. So if I'm just able to zoom in a little bit, MEDV is now a column added to the new data frame and contains all the values present inside the target key. Okay, all the values present inside the target key is now inside your MEDV that has been appended, that has been added to the entire data frame. Why MEDV? That is a name. You can assign anything. That's totally up to you. I've just assigned it randomly. Okay. So again, if I'm just comparing it, the last column that we were having was LSTAT. That was the last column that we were having. But now we are having MEDV at the end of the entire thing as well. Okay. MEDV basically is the short form for median value. Okay, median value of that particular type of house. Okay, that is a median value that I've just shortened it to MEDV. That's just a name given to the column. You can have it anything. You can have in predict. You can have it like target. You can have in SDAK. You can have in Sega. It can be Nintendo. It can be Mario. It's totally up to you. That's just a name. Okay. Okay, check if the data set contains any null values or not. We already know that because from the description itself, we have already known that there is no null values in the entire data set. So that is where the description actually helped us a lot. We already knew that there are no null values in the entire thing. I'm just cross checking it right now just to know that is there any null values present in the entire thing. So we'll be just writing Boston.isNull. That will basically check if there is any cell present. So this is basically a table. This entire data set is basically a table itself. So inside the table, it will check for each and every cell that I'm having. So in a table, you are having your rows, you are having your columns, and for each of those intersection, you have a cell. So Boston.isNull is a particular function that will check whether a particular cell is null or not. If it is a null, then it will give us true. If it is not a null, it will give us false. So when I'm doing Boston.isNull, I'm seeing that it is giving me an entire matrix of 505. So it is starting 506 rows and 14 columns of false and true values. Okay, having a 506 rows and 14 columns having true and false values. I cannot check if there is any null values or not from this data. I cannot check that, and that is where we are going to use another property. Okay, another property that we are having, that is sum. What we are going to do is we are going to do Boston.isNull, that will give us this entire table of true and false values. False means there is no null value right over there. True means there is a null value in that particular cell. Okay, so when I'm running this particular line of code, I'm having Boston.isNull.sum. Sum will take each of those columns. Sum will take each of those columns and do a sum for all the values present in that particular column. False when converted to integer means 0. True when converted to integer means 1. So if there is any null value present in that particular column, then you will be returned the number of null values present in that particular column, because every null value would be having a value of true, that is 1. So if there are 4 true values in the entire column, it will be 1 plus 1 plus 1 plus 1, and the rest of the entire thing would be 0. So you will be getting 4 as your output, the number of null values present in each of those columns. So Boston.isNull, that gives us the matrix of false and true values, and then you will be doing .sum. Okay, then you will be doing .sum right over here, and that you are able to see that each of the columns, each of the 14 columns contain no null values. Each of the 14 columns contain no null values whatsoever. For those who are not able to understand anything, do not worry about it. You will be making the entire project using this same video. I think so that you are not able to understand because you left in the middle or you were not able to focus on the lecture itself. Do not worry about this. This video is getting uploaded on YouTube for the rest of your life. So while making the video, while making the project itself, just refer to the video, listen to me properly, and you will be able to understand every single thing. Do not worry about the same. Okay. So that is what I'm trying to make you guys understand right over here. You are having all the different columns, and there are no null values present in the entire data set. So that is something that is already known by the description itself. This is not necessarily just something additional. So if you want to check it on your own data set, you are able to do it. Okay. So moving on to the next thing. Now what we are going to do is we will train the model on all the data that we have. We make sure that at least, okay, so we are being given the guide. Okay, we are having the entire data set. Think of the entire data set as your guide itself, the guidebook that we talked about. Now we need to make the training data on which we'll be giving to the models so that it is able to learn from that, and the testing data that we need to create to check if the model is doing well or not. So we need to divide the guidebook into 2 different values. Okay. Okay, so isNull will basically check each and every cell present in the entire table and see if any cell is basically containing a null value. So it will give us true for that particular cell. If that particular cell does not contain a null value, then it will give us a false value. That is what I'm trying to make you guys understand. Okay. Okay, so again, we are having the entire data set. Okay, the entire data set is basically like your guidebook. Okay, your entire data set is basically like your guidebook. We need to separate the training data, that is the data on which the students will be learning, and then the testing data upon which we can test the student that, okay, is he performing good or not? Has he learned everything? Has he underlearned everything, or it is perfect? That is what we want to check right now. So we need to divide the entire data set into training data and testing data. That is very easy using sklearn. Okay, extremely easy using sklearn. So from sklearn, okay, I'll just separate it into different lines so that it is a little bit clearer. Otherwise it will look very shabby. Okay, so from sklearn, okay, that is the library for machine learning. It contains many different things. That is what we are going to use to divide the entire guidebook, to divide the entire data set into your training data and your testing data. So sklearn.model selection import train test split. Okay, sklearn.model selection import test train test split. So as from the name itself, you are able to understand that this function will basically help me to split the entire data into training data and testing data. This function will help me to divide the entire data set into training data and the testing data. So we already know, we have already discussed why do we need a training data and a testing data. So this function will help us to do that. Okay, so x is equals to boston.drop. Okay, so first of all, we need to divide the entire data set into two different parts. That is the data containing all the different columns, that is your x, and then your y as the data containing your target values. Okay, you need to use x to predict y. Okay, you need to use x to predict y. So x is a data frame that will contain all the different columns except the MEDV column, that is median value column. X will contain all the columns in the entire data frame except the MEDV column, because we are going to use x to predict that MEDV column. Okay, and that MEDV column will be calling it as y. That is what I'm trying to make you guys understand. We'll be using x. Okay, so let us try to draw it and understand. Here's the pen. Here it is. So we are having the entire thing. You're having the entire data frame right over here. You're having two parts for the entire data frame. Okay, of course, all the different columns that are present right over here. So just drawing dot 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 dot. You are having the value x. Okay, the x is basically just this part of the entire data frame. X is basically this part of the entire data frame x, and y is basically your target values that you want. Okay, the target values that you want to achieve. Okay, that is your prediction. What do you want to predict? So that is your y right over here. So we want to create an x data frame and a y data frame right over here to then utilize to make just to separate the entire x and y. Okay, that is what I'm trying to make you guys understand as of this particular point of time. Okay, so right now what we are going to do is we are having your boston.drop. So x, we are creating another data frame. Okay, it's a new, we are creating a new data frame. X is equals to Boston. We are going to use the previous data frame that we are having, the Boston data frame, and we are going to drop. So drop will basically drop the data frame from drop a particular column. So here axis is equals to 1 basically means you have to drop the column containing the name that have the name of MEDV. Okay, we want to drop the column containing the name. We want to delete the column containing the name MEDV. Axis is equals to 1 means you want to drop a column. Axis is equals to 0 means you want to drop a row. Okay, so here we want to drop a column. So axis is equals to 1 and the name of that particular column is MEDV. Here you are not deleting the entire column in place. You are first making a copy of the entire Boston data frame. You are making a copy of the entire Boston data frame, and from that copy you are deleting the last column and you are assigning that to x. Okay, so let us go back to our drawing board. So what you are doing right over here is you are having your Boston data frame, the original Boston data frame, as you are able to see from right over here. It has two parts, the x and the y. Okay, you want to create the x. So what you're doing is when you're writing Boston, okay, when you're writing Boston.drop and then the name of that particular column, comma, axis equals to 1, what it is doing, it is creating a copy of the entire data frame. So this is the original. Okay, this is the original data frame. You are making a copy of the same. So this is a copy of the entire same thing, and from that you are deleting the last column that is called as MEDV. It is having axis equals to 1. Axis equals to 1 means that I'm deleting a particular column named as MEDV. So it will delete this particular column. It will just delete the last column called as MEDV from right over here. And I'm assigning the rest of the entire thing. So these are the two parts of the entire thing. I'm assigning the rest of the entire thing to x. Okay, so this is x is equals to this particular part. And this is a copy of the original. So original is remaining unchanged. The original is unchanged, unchanged. Okay, it is unchanged. We are using x as capital because it does not matter. You can use small as well. It's a variable name. Okay. Yeah, that's absolutely correct, Amay. Axis equals to 1 means your column, and axis equals to 0 means your rows. Okay. Why are we deleting the last column? Because x basically like x, you need x and y values. You need x that is going to use to predict y. Okay, you want to use x to predict y. Okay, to do that you need to have only the values that you are going to use to predict y. Okay, if you are including y in that, then of course it will just use the last column to predict y. There is nothing, it will not even give an entire attention to anything else, because you are having the answer inside the question itself. You need to separate the question from the answer in the guidebook. You need to separate the question and the answer in the guidebook. Okay, that is what I'm trying to make you guys understand. What is the need of axis equals to 1? Because you need to delete a column. You need to delete a column, you need to specify axis equals to 1. If you want to delete a row, you will be specifying axis equals to 0. Okay. Right over here, we have created our x is equals to boston.drop medv, comma, axis equals to 1. And then your y, that is the values that you want to predict as boston medv. You just want the medv column. So you can just access that by writing boston medv, and that will give you the access to the last column that is present right over there. Okay. So next what we are going to have is, we are going to make the x train. So you are going to make the test and the train values. Okay, train and the test values. Okay, that is what we are going to do. Okay, we are going to make the x train and y train, and then x test and y test. Okay, so for every train and test values, you are going to have its very own x and y and x and y. Are you able to understand this? For the train values, the train portion of the entire data frame, you need to separate the question and answer, question and answer, question and answer. For the entire testing part as well, you need to separate the question and answer, question and answer, question and answer. That is why we need to separate the train. So we'll be creating x train, y train, and x test, y test. So we'll be having these two separate. So we'll be creating 4 different things. The syntax for the entire thing. Okay, the syntax for the entire thing, how to do the x train and test split. Okay, for that we are going to have x train, comma, x test, comma, y train, comma, y test. So this is a tuple that we have created right over here, x train, x test, y train, y test. So we have made a tuple right over here. What is test and train? We have already studied about it. If you remember the guidebook, the training guidebook is something that is given to the student so that he is able to learn from it, and the testing part is what the student gives the test upon. Okay, that is what I'm trying to make you guys understand. So x train, x test, y train, y test. We have made everything that is equal to train test split. Okay, we want to split the entire training and the testing part. Then we'll be having your x comma y, that is your x, and the y we want to put it as an input. Trains test size. Okay, so what is the going to be the size of the entire test? Okay, so what is going to be so you are having 100 different rows. Okay, for example, you are having 100 different rows in the data set. How many of that are you going to put inside your test set? Okay, how many of that is going to be put inside your test set? So I want 15 out of 100 questions. I want 15 out of 100 question and answers to be put inside of the test set, and the rest of the 85 question and answers to be put in your training set. So for that, I will be specifying test set 0.15. That is, out of every 100 question and answers, every 100 data points, every 100 rows that I'm having, 15 of that will be put inside. Okay, inside of your test set. Okay, that is what I'm trying to make you guys understand right over here. Okay, then you're having random state is equals to 5. So what is random state? Now this particular test size, okay, which particular data points are going to be in your test set, which particular data points are going to be in your training set, that is selected on a random basis. Okay, that is selected on a random basis. So if you're not putting up any type of random state, so random state is basically nothing in a particular computer is truly random. Okay, you are having a particular function, you are having a particular function in the background that basically chooses things in random. This random state is equals to 5. If you're setting it to any arbitrary number, you are setting this to 42, you are setting it to 0, you're setting it to 1, okay, any random number that you're setting it to, it will work for that. But set it to any particular number, so every time when you're running this particular line of code, it will choose the exact same test size. Okay, so for 1 it will be choosing like 4, 5, 6 as your test in your test particular data set. If you are using like random is equal to 5, it will be choosing 6, 7, 8. But every time if you are using 1, then it will be choosing the same numbers again and again and again. Okay, that is what I'm trying to make you guys understand. I'll explain this line again, guys. No problem in that. You are having your X. So you want to create your train and your test data set. Okay. You want to create your train and your test data set. The train will contain your X train and Y train. Your test data set will contain your X test and your Y test. Okay. That is what I'm trying to make you guys understand right over here. In your train test split, this is a particular thing that we have imported from sklearn.model selection. So train test split will split the entire data set, the current data set that we are having. So X is basically containing all the data that we are having of the columns, and Y is basically containing the prediction values. We are having your X and Y as your input. Test size is equal to 0.15. That determines how many question and answers, how many data points you want to put inside the test set, okay, inside your test data set. Okay, so 15 out of 100 should be put inside your test data set. 85 out of 100 will be put in your training data set. And then you want to select random state is equals to 1. Random state selected to any particular number. Why we are doing that? So that every time when you are reading this code, if I'm giving this code to you, when you are also running this, it will select the same 15 data points for you as well. It will select the same 15 data points for you. If you want to change it, just change it to 5, and that will change some other set of 15 data points for you in your test set. Okay, just try to understand, this is just so that the train and the test set remains the same no matter which computer you are in. No matter which computer you are in, that is why I'm trying to make you guys understand. Are you guys able to understand this? Please let me know, guys. Okay, great. Okay, so next I'm going to show X train, X test, Y train, Y test. Everything is basically again your data frames itself. So I want to see how many number of columns and how many number of rows does each one of them contain. I'll be just writing X train dot shape, that will give me the shape, that is number of rows multiplied by number of columns that is present right over here. Then you are having X test, you are having number of rows and number of columns present right over here. So I'm running this, you will be able to see that I'm having 430 rows in your X train and 13 columns. In your X test, I'm having your 76 rows and your 13 columns, again the same. Inside your Y train, you are having 430. So X test, X train and Y train will be having the same number of rows, okay, because they need to be exactly the same thing. So 430 rows and 1 column, because it's just the prediction values. And then you are having Y test, that is containing 76, that is of course the same, that is the question and answers, and then 1 column right over here. That is what I'm trying to make you guys understand. Okay, so now let's import the linear regression model from the sklearn and train it on the training data set. So we have created the X train and Y train, okay, on which we want to make our linear regression model. So that is our ML model with the algorithm linear regression inside of it. We want it to be trained on our X train and Y train, the X train and Y train. 13 is the number of columns that we are having, guys. 13 is the number of columns that we are having right now. So right over here, we are going to import from sklearn.linear model, import linear regression, and from sklearn.matrices, import mean square error. So mean square error is basically just to know how much error is there in the entire predicted values from what we expected from it. I will just go into that in 1 second. Just like, please wait for the same. Okay. So again, so we do not need this. This has already been done. So I'm just removing this from right over here. Okay. So we are importing the sklearn.linear model, import linear regression, and then from sklearn.matrices import mean square error. Okay, I'll be discussing about mean square error in some time. Please let me just be patient. Okay, so I'm just importing both of these from right over here. Then we are going to fit the entire training data set. So you have the model created, so make the model. You are having the name of that model as that is linear model. Okay, LIN underscore model, that is the name of the model that we want to create. To create that particular machine learning model, I just need to call the linear regression function that we have just imported right now. Okay, so I've just imported that particular function, and I've just used it to create my machine learning algorithm. Just in 1 second, your machine learning algorithm has been made. In 1 second, your machine learning algorithm has been made just by writing this entire line. Just by writing this entire line, you have made the entire machine learning model. Okay, now you need to feed in the data set to the model. Okay, you have created the student, you have become a god, you have created the student. Now you need to feed in the training guidebooks to the students. Okay, the question and the answers, you need to feed it to the student itself. To do that, you are having your LIN model, that is the model that you have created. Okay, and then fit, that is you want to fit the X train and Y train to it. Okay, the X train and Y train, that is what we want to do right over here. Okay, lin model dot fit X train and Y train. When I'm running this particular line of code, it will fit the entire data, entire training data to the machine learning model. It will fit the entire data into the training machine learning model directly. Okay, into the machine learning model directly. So when I'm moving back into the next line, so we have created the model, we have fit the entire training data inside of it. Now we want to just predict it. Okay, that's it. We want to do the prediction itself. Just 2 more blocks of code, guys, and that's done. Okay, the entire project will be done in just 2 more blocks of code, guys. So please just be patient. Okay, so we wanted to see mean squared error. We will be discussing about that right now, so just wait for a second. So y train dot predict is equals to lin model dot predict X train. Okay, so we want to make the predictions. We have trained the entire model. Now we want to make the predictions from that. So to make the predictions on the training data set, so there are 2 predictions that we need to do, 2 tests that we need to do. Okay, the first test, we need to take it on the data that it has learned right now. There are 2 tests that we need to do. One of the tests is on the data that we are having right now. Okay, the training data itself, we need to take a test on that, and separately we need to take a test on the testing data itself. So now it is the time to make the test. To make the test, it is very simple. The model name, that is lin model, that is the name of that of our model itself, dot predict, that is you are given the X train data set, predict the values, what should be the answer according to you. You are telling the model what should be the answer according to you. So you are having a lin model dot predict the answers for the X train if X train was given to you as an input. You are telling the model predict the answers if X train was given to you as an input. So you will be doing, okay, so Y train predict is the answer that you are getting right now. Y train predict is the answer that you are getting right now. So think of it as in such a way. Okay, you are having the model. Okay, you are having the ML model. You trained it on that. Now you are feeding in the X train once again. So this is trained. Okay, this is trained. This is trained right now. It has been trained. You are feeding in the X train right now, and it will give you out Y hat. Okay, Y hat train. Okay, this is the predicted values. Okay, this is not the original values. This is the answers written by the student in the test when you were giving the questions of X train. When you were giving the questions of the X train, whatever answers the student writes inside the entire question paper, the answers that the student is writing for the X train, that is your Y hat train. And the answers that were written in the guidebook were Y train. Okay, these were the answers written in the guidebook itself. The student has given Y hat train as the answer. Okay, this is the original, this is the predicted. Now we want to check what is the error between them. We want to check what is the error between them. So the most easiest way to do that is we can just we can just take up the difference, the square. Okay, we can square both of the things. Okay, we'll take both of the things, we will square them, and then we'll subtract them, and then we'll do under root. This is the entire, like this entire thing that we have done right over here, squaring the both the values, the original value and the predicted value, and then just to minus it, to subtract it. Okay, that is basically called as your mean square error. Okay, that is basically called as your mean square error. Okay, that is what I'm trying to make you guys understand. Then divided by like 1 by, so that is also there, like 1 by the number of rows that were present. So here like 467 rows almost are present, so I will divide it by 464 to get the error that is present in the entire thing. So that is what is called a mean squared error. So squaring both the units, you are you are subtracting it and then dividing it by their number of units that were present right over there, number of instances that were present right over there. So that is basically called as a mean squared error. What if it turns out to be negative? That's why we are actually squaring the entire thing. Okay, that's why we are squaring the entire thing, so that, and we are going to take an absolute value of the same, so that there is no negative values whatsoever. Okay. Okay, let's move on to the entire thing. So what we are going to do is np dot square root mean squared error is a function that we are going to use. So instead of doing all the calculation by ourselves, we are just going to write ytrain and ytrain predict. That is the prediction that we have done, the predicted values that we are having, and ytrain is the original values that we wanted. Okay, and we are going to do a mean square error function over that, so that will do the entire computation for us, and we need to get the square root for the entire thing. So we'll use the np dot square root, because this is basically a like entire tables itself. This entire thing is a table itself. Okay, so we are getting np dot square root from right over there. Okay, np dot square root from right over there. So np dot square root mean squared error ytrain predict. Okay, so we'll do a square root for the entire thing, and that will give us the RMSE value. Okay, the root mean square error. Okay, that is the entire thing. So again, for the testing set as well, we need to test the entire model. Okay, first of all, we need to create the test for the entire model. So we have the model name. We want to predict the values based on the input, based on the questions of X test. Okay, so X test is something that we are going to give right over here. Okay, X test is basically something that we are going to give right over here. Okay, so next let us move on to, okay, so we are going to take up the model. We are going to do a predict on it. Okay, the predict is X test. We are going to use X test as our questions, and we are going to make predictions upon that, and we'll get the Y test predict as our answer. Okay, the prediction values on Y test. Now Y test is basically your values that you wanted from the like model, the values that you wanted from the models on an unseen data. Y test, X test was your unseen data. Okay, so the values that you wanted from as like answers, that is your Y test, and your Y test predict is the answers that the model gave it to you. So having your np dot square root mean squared error, and then when you are running this particular 2 lines of code, you are getting the model performed on the training set with an error of 4.71 something. That is a good error, not a very lot of error. There's a little bit of error in this. And the model performance on the testing set was 4.68. So it's almost very near to the training data set itself. So both on the testing data set as well as the training data set, you are getting the same error, almost the same error. The model performed beautifully. Okay, the model performed very well. Okay, it was a very simple thing. So we can just like, this portion is something that you do not need to code. Okay, do not need to code. Okay, you do not need to code this particular thing. This is just for your information purposes itself. You do not need to code it. I will not be discussing the code for that. I'm just trying to show you guys the entire thing. Okay, so the actual values are basically presented, like if the value, actual value was 10, and the predicted value was what was the predicted value. So the actual value was right over here and the predicted value was right over here. The actual value was right over here, okay, and the predicted value was, so actual value was approximately 20, but the predicted value was approximately 0. Okay, so these are all the data points, like, and their like actual and the predicted values. If you have your actual values, your y test and your y predicted, y test and your y test predicted, if you're plotting that on a scattered plot, okay, a scatter plot is very easy. Whatever values you are having on one end, the y test, and then associated values on the y test, like on the y test predict. Okay, between that, if you are making a plot, it will look something like this. And as you are able to see, for most of the data set, it was very close. It's a straight line. It is very close. So most of the like predicted values were absolutely perfect. Some of the values were not so well predicted, as you are able to see, those which are not like upon that particular line. But as you're able to see, almost all the values were predicted like correctly itself. That is what I'm trying to make you guys understand from this particular diagram. Okay, so that is the entire project, guys. Very small project, like less than 20 or 25 lines of code. Just come back to this particular video, listen to the video properly, and you will be able to understand everything. Okay, most of you were not able to like pay attention for the entire thing, and we were short on time as well, so I had to rush forward with the entire thing. But when you will be listening to it again, you will be able to understand every single thing. Okay, you do not need to make the graph. That graph was separate. You do not need to make the graph. That was just for your understanding purpose itself. You do not need to make any graph. Okay, yes, you can use Jupyter. You can only submit the project as an IPYNB file. How to submit the project, where to submit the project, that will be said to you in a separate video. Do not worry about the entire thing. Okay, this file will not be shared with anyone. You will have to come back to this particular video, listen to it properly, and you will be able to do it. Okay, this is the same project that you have to build, exact same project without the graph. You have to build the exact same project without the graph. Okay, okay, so how to make the project? It is very simple. I will be telling you guys in a separate video as well. Do not worry about that. Just to make you guys understand, collab.research.google.com. You just have to go to that particular website. Okay, you just have to open up a new notebook. Okay, from right over here, you have to select the new notebook option. You just go to a new notebook option, and then you just have to make the entire project right over here. You do not need to have any comments. You do not need to have any text. Just the code, nothing else. Just the code and nothing else. Okay, you do not need to have any type of comments. You do not need to have any kind of text. Just the code. Okay, how to submit the project, where to submit the project, I will be making a separate video on that, uploading it on YouTube. You will be able to, I will be sharing that link with all the WhatsApp groups as well as the Telegram channel. So do not worry about it. Every single thing will be told to you guys. The project will not be provided to anyone. You have to do it on your own itself. Okay, so that is also one of the things. Okay. Okay, for the data analyst training and internship program, all the full stack development and internship program, from tomorrow it is going to start. If you guys are interested, do join us. Otherwise, we'll be continuing with the same. Okay, okay. So thank you guys, and we'll meet forward with this. Thank you so much. Thank you.